Good evening, everyone. My name is Darshni, and daughter of Muthukrishnan. Today, we are assessed to present your project on amplitude modulation demodulator. The introduction is AM is widely used technique in communication system where the amplitude of the high frequency carrier wave is verified according to the message signal. However, to revive the original message, we need a AM demulator. Let's see important of AM demulation. AM demulation is technical because it allows us to extract the transmitted message from the modulator carrier wave. Without demodulation, the information could remain embedded in the high frequency signal and be unreadable. Some key application of the demulation in demulator AM receiver, aviation communication, and the telecommunication. Let's see type of AM demulator. There are several techniques for demulation AM signal. They are envelope detector, synerosic uh, demulator, square law detector. Let's see the purpose of the system. Your AM demulator consists of three main components. They are receiver, low pass filter, and the amplifier. The receiver is convert the AC signal to the plastic DC signal using diode. The low pass filter remove the higher frequency component and leaving only the basement message signal. The amplifier exchange the extract signal for the better calibration. This is the block diagram to demulator. The first one AM signal to the rectifier to low pass filter, then require the message.
Hi, my name is Dinesh Kumar. Today I'm gonna present CST project. So today I'm gonna talk about design. The design of the AM demulator follows a structure approach. First, the envelope detection technique is selected as simplest and most effective method for AM demulation. The circuit consists of diode, a capacitor, and resistor to recover the original message signal. The design process involves selecting component values and verifying circuit through simulation before implementation. So moreover, reasoning for design steps, the AM signal source is chosen to generate a 400 kHz carrier wave with a 10 kHz message signal representing a typical AM radio frequency. A diode is used to rectifier due to its fast switching characteristics, ensuring effective detection of high frequency signals. The capacitor, which is 0.01, and resistor 1 kilo ohm, are selected based on their ability to form a low pass filter that smooths the rectified signal while preserving the modulating waveform. The choice of these components ensure that the demulated signal accurately follows the envelope of the AM waveform. So the next is circuit diagram. The circuit diagram is finalized design is simulated using software to verify performance before physical implementation. The circuit is then assembled on a breadboard and on a oscilloscope and used to observe the input AM signal and demulated output. The results confirm that the circuit successfully tracks the envelope of AM signal, validating its operation. So, implementation with commercial components. Reason behind choosing specific components. Number one is diode, which is 1N4149. The diode is chosen due to its fast switching properties. He His main functionality of this diode is the same as a normal switch. This diode have a high resistance under a fixed voltage where they have a low resistance above the fixed voltage. So the number two is capacitor. Capacitor is used to low pass filter to smooth the rectifier signal. Unlike the battery, a capacitor in a circuit component that temporarily stores electrical energy through distributing charged particles on plates to create potential difference. A capacitor can take a shorter time than a battery to charge up. It can release all the energy very quickly. So the last is resistor. A 1 kilo ohm resistor is used to set the cutoff frequency of the low pass filter. A resistor is an electrical component that limits or regulates the flow of electrical current in an electronic circuit. Resistor can also be used to provide specific voltage for an active device such as transistor.
Hi, my name is Nilesh Murugan and today I'm going to present about my Csd Lab project. So I'm going to talk about the results and the discussion. So now I'm going to talk about the simulation testing. We test the design circuit in multi-sim. So the circuit is tested with an AM voltage to produce modulating signal. The circuit is tested with a carrier frequency 400 kHz and an information signal frequency is 10 kHz. The circuit is successfully managed to retrieve the information signal from the modulated signal. Therefore, the circuit we design is able to separate and get the information signal without any distortion. Okay, now I'm going to talk about the hardware testing. We managed to buy the components needed for this project and build the design circuit. The figure shows the construction circuit of the modulator. This circuit also tested with the same frequency. The first group will do the modulator circuit with the same frequency and able to produce modulated signal. The output of the modulator is connected to the input of the demodulator. Then the demodulator circuit is able to retrieve the information signal from the modulated signal produced by the demodulator. As we know, the demodulator circuit successfully gets the information signal. It segregates the higher frequency signal through the low pass filter. And the diode only allow currents to flow in one direction, either the positive or negative half of the signal. The capacitor removes unwanted RF components from the output, leaving a signal similar to the original modulating signal. However, because the capacitor charges and discharges, there is a small ripple that causes slight distortion. Since the carrier frequency is much higher than the modulating frequency, this ripple is usually unnoticeable. Both simulation and hardware results show similar outcomes, though the hardware result has a bit more distortion, possibly due to some small error or noise in the lab equipment.